Now coming on to Cohens D. What do I do with Cohens D? Cohens D, in the case of independent group data which has pooled variance, what I do? I take out the standard, the square root of the pooled variance, which is the standard deviation. Okay, so I find out the mean difference between the two population divided by the standard deviation of the pooled group. Okay, I have already calculated the pooled variance. I take the root of that pooled variance and I get the value. Now I do some mean 1 minus mean 2 divided by the pooled value, the pooled standard deviation. So here my denominator is standard deviation. Note, it is mean 1 minus mean 2 divided by standard deviation of the sample. And that's pooled again. Clear? And that gives me a value of, let's say, 0.36. Again, as my Cohen D value increases. So what I can say here, as my standard deviation values increases, my D value reduces. If my D value reduces, my effect becomes weak. Okay, as my D value reduces, my effect becomes weak. Clear? However, if my standard deviation is less, that means the variance that I am showing in the population is less. That means my D value would be higher and the effect would be higher. That means more of the variance in the dependent variable could be attributed to the independent variable. That means I can say the changes that are seen in the dependent variable can be attributed to the independent variable, and that's what I was actually making to understand. So let's say there is a case where both these values, the sum of effect and the sum of totals in the case of eta squared, let's say, are same. That means my eta square value is 1. That means the effect is highly strong. Okay, so Cohens D is the measure of standardized difference in the means divided by the sample standard deviation. Okay, and that too pooled in the case of pooled variance. So in the case of unpooled, we would go with the S1 square plus S1 square root divided by root n1 plus S2 square root divided by n2. Okay, so that root n2. So that's how we calculate it, as we have seen in the formula already in the case of t-test. So if you want, I can go for the unpooled one again. So let me go for the unpooled variance again. So in the case of unpooled variance, this is my standard error. So I don't need to find out the standard error here. What I need to find out is just the standard deviation. So standard deviation is root of S1 square plus S2 square. So root of those would be the standard deviation. Clear? Now, once I have calculated Cohens D, this is the formula for the pooled variance, as we have already talked about. So I am taking the pooled variance and I am taking the root of that pooled variance to give me the pooled standard deviation of the sample. Now this pooled standard deviation of the sample would be in the denominator. So mean difference divided by pooled standard deviation of the sample would be the Cohen D.